So as I told you yesterday's class, 16th question is basically is a very important question. So because it is purely concept based question. So what they are saying exactly, you see that it's very simple, but just you have a knowledge. The weight of a person on a planet A is about half that on the Earth. So there is a two things. One is Earth, another one is some planet A. So let consider weight on the Earth is W. Then weight on the planet, if I take the planet, so the weight become half. That is what, let me take W dash, which is equals to W by 2. Half of the weight on the earth. Do you understand everybody? Then he can jump up to 0.4 meters height on the surface of the earth. So if he try to jump in the surface of the earth, he can jump maximum up to 0.4 meters. That is the maximum height he can jump. Then how high he can jump on the planet A, he is asking. So that is what H dash. So observe very carefully here. The concept is the mass of the bodies remains constant. Because why? Same object is jumping. So two different objects are not jumping. So what will happen, everybody? The same man actually, the weight of a person means the mass of a person is remains constant. So a man can do the same amount of work done on the earth and as well as on some other XYZ planet. So by keeping that means in the sense of the effort of man, the effort of the man on the both the places in the earth and as well as planet is remains same. So the effort of the man is same on the both the places. As he is jumping means what energy will come? Anybody? Going above from the ground, what energy will comes? All of you? Going above from the ground, what energy will come? Everybody?
Potential energy.
Potential energy. So potential energy in this case, let me take potential energy here. And here the potential energy also, both cases energies remain same. Because he is doing the same effort, because same person, same mass. So in this case, the potential energy is mgh. In this case, potential energy is mgh dash. Understand, everybody? All of you? Clear? So now, here what they are saying, see, now here G, it is not G. Why means, as we all knows that weight is equals to mg. If weight is directly proportional to G. So now see, from the earth to the planet, weight become half. Means G also become what? Everybody. G also become what? Half. Do you understand? Mari, clear? So when weight become half, G also becomes half. So here I am taking the G value on this planet is G by 2. Here the G value is G. So if I equate this both, you'll get the answer. So mass is remains constant. GH is equals to G by 2 H dash. Now GG will get cancelled. By 2 will come this side. That is what 2H. So H dash is equals to 2H. So H dash is equals to 2 times of H value is 0.4, which is equals to 0.8 meters. So very, very important question. So please remember, if weight become half, G value also become half, but only the effort is remains same. So if the effort is same means the potential energy gained by the man is remains same in both the things. That is what on the earth also and as well as on the planet also. That is what you have to remember. Understand, everybody? Clear, all of you? Yes, please.
Yes, sir.
Yeah. So that's why I'm saying. So this is little logical mind, and as well as you need to have a complete knowledge and concept. So that's why you have to learn this. Very important question. Right. Next. Clear? Jai Krishna, understand? Next.
Yes, sir.
17th question. So let us see a few questions we'll solve. As standard class, they're asking many things. Next question. All of you see that. The velocity of a body moving in a straight line is increased by applying a constant force. Constant force. That is, you should remember. For some distance in the direction of the motion, prove that the increase in the kinetic energy of the body is equal to the work done by the force on the body. So again, all of you read the question. So if you read the question, you'll make it. So what is the question they are saying? A constant force is applied. Constant force is applied on which body? The velocity of the body moving in a straight line is increased by applying force, constant force, for some distance. So by this time, your mind should say it is something. Anybody? What is that? Work energy. What is this? Work energy theorem. What they are saying, you see, the velocity of a body moving in a straight line is increased by applying a constant force for some distance in the direction of motion. Prove that the increase in the kinetic energy of the body is equal to the work done by the force on the body. Do you remember, everybody? Work energy theorem, please respond. Work energy theorem. So that is only the answer for this. Means a body is already moving with some initial velocity u. So constantly you apply some amount of force. So after traveling certain distance, the velocity become v. So now they are saying the kinetic energy increased. Means that is what? Change in kinetic energy is equals to amount of work done. So what is that? Everybody formula. Final kinetic energy minus, respond Ra, initial kinetic energy. That is only the work done. Do you remember, everybody? So the proof, if you want it. So again, we'll go with that. So what is the work energy theorem proof you have written? Verify, everybody. I want it immediately. Everybody has to check your notebooks and tell me. Proof. What is work energy theorem will say states that. Everybody. The total work done by a body is equals to what? If you are not saying, I will never teach. I am saying. The total work done by the body is equals to something. Statement for work energy theorem. See that and tell me, everybody. What is the statement you written? Work energy theorem. A total work done. Is there anybody in meeting? A total work done on a body is equal to the change in its kinetic energy. Do you remember, everyone? All of you? Hello? Am I audible, guys?
Yes, sir.
Yes, sir. So, we have considered initial velocity of the body is u and final velocity of the body is v and distance traveled is s and applied force is f. So, if you have been taken this, then we all knows that force is equals to mass into acceleration. And from the third equation we have find v square minus u square is equals to 2as. From that, s is equals to v square minus u square divided by 2a. So we all knows that work done is equals to force into displacement. So force is equals to ma. Displacement is equals to v square minus u square divided by 2a. So what will happen, everyone? Speak, guys. A will get cancelled. So work done is equals to 1 by 2 will come front m v square minus u square. That is only is equals to change in kinetic energy. So which is equals to change in kinetic energy, which is equals to amount of work done. So this is what we used to call it as, what is to say, work energy theorem. You cannot forget everything, whatever you studied. Formula for kinetic energy. After that, work energy theorem only we studied. Am I right or wrong? Everybody, verify it. Yes or no?
Yes.
Learn. Simply sitting means
Yes,
nothing
sir.
is going to work out. Please remember that. Okay. Next, right. Very, very important. Next question. Is it possible that an object is in the state of accelerated motion due to external force acting on it, but no work is being done by the force? Explain it with an example. Let me see who is having knowledge. 100% you are having this. This concept you know. It is accelerating continuously, but total work, coming to the work done is zero. Anybody can tell what is the example? I'll give the clue also. You studied last chapter. Yes, at least now. Last chapter you studied that. Question you understand. What is the question they are saying? All of you observe. Everybody. So the question is,
Momentum.
what are you talking, Mari? First read the question, Mari. That's the problem I'm saying. Momentum where the work done is zero, Mari. Tell me. From the first chapter. I will explain. So from the first chapter we studied what? Circular motion. Do you remember everyone? Circular motion. It is not circular motion. We have kept a little more big heading. Anybody can tell that heading? Agalya? Yes, please. Uniform circular motion. All of you remember that? Yes or no? So please remember, acceleration actually changes by two different ways. Acceleration is a vector quantity or scalar quantity, everybody? It is the vector quantity. So we can change the acceleration by two different ways. One is by changing the magnitude of velocity, magnitude of speed or velocity. Second one is direction. Am I right or wrong? Everybody, please respond. So direction. So if it is in circular motion, at every point, the direction is remains same or keep on changes? Everybody. Keep on same, remains same. The direction is remains same or different? At every point, changes. So that's why we studied uniform circular motion is an accelerated motion. Do you remember everybody? All of you? Our last chapter we studied gravitation. The planets are revolving around the sun continuously in an accelerated motion because they are continuously changing the direction at every point. But they all are revolving because of external force. What is that force which is acting towards to the center? What is that force?
Centripetal force.
Centripetal force. So they all are revolving. Is it possible that an object in the state of accelerated motion due to external force acting on it? What is the external force acting here? Everybody? What is the external force acting
Centripetal
here?
force.
Centripetal force. Centripetal force. Centripetal force is acting. But it is, and of course, it is continuously accelerated motion because direction of velocities keep on changes. Velocities keep on changes. Maybe magnitude is remains constant. Magnitude of velocity we used to call something. What is that call it as? Magnitude of velocity we used to call something. What we used to call? Speed. So speed of the body may remains constant. That is call it as a uniform circular motion. Speed is constant, uniform circular motion. Speed is not constant, non-uniform circular motion. But uniform or non-uniform object is in the circular track is always accelerated motion. Why? Direction is keep on changes. So if direction is changing, it is said to be accelerated motion. But no work is being done by the force. Why? Anybody? Because what is the angle between the force and displacement? Everybody?
90 degree.
90 degree. Everywhere the angle between the force and displacement is 90. So that, what is the work done? Everybody? Yes, please. What is the work done? All of you?
Zero.
So write the answer. I will say you. Answer you write. 18th question. Very, very important question. Yes, it is possible. Yes, it is possible. Yes, it is possible. When an object is in circular motion, when, do you all understand everybody? Please. When an object, are you clear, Amma? When an object is in circular motion, when an object is in circular motion, then the centripetal force is, perpendicular, is perpendicular to the direction of motion. Direction of motion means what is the angle between them? Theta is equals to, everybody, theta is equals to 90. Okay. Hence, work done by the centripetal force. Work done by the centripetal force is 0. But circular motion is a what motion? Everybody. Circular motion is a what motion?
Uniform motion.
Accelerated motion. Circular motion is a accelerated motion. That is very, very important. Please, all of you write. Understand that? Mari, Hasini, understand? Gokul, Kishore, any doubt, anybody can ask. Clear, everybody? Mukesh Kalyan, understood? Hiroshi, Shivani.
Yes, sir.
Yeah. Very, very important question. See, this is what looks theory questions, but concept purilla, answer is not possible. So you have to do it. Make it quick, everyone. Anything doubt, anybody can ask. Make it quick. All of you clear?
Yes, sir.
Yes, sir.
Lingesh, Kishore, your next question answers. Just to make it, just a minute. Yes, next question you read. Everybody? What is the next question? A ball is dropped from a height of how many meters? 10 meters. If the energy of the ball reduces by 40% after striking the ground, how much high can the ball bounce back? One of the most important question. So it's very, very good question actually. So like we can say it's mathematics concept plus physics here, everything it is. So like you see, if you drop any kind of ball towards the ground, definitely the ball will be bouncing back. Am I right or wrong? Everybody? Yes, please. All of you? Please respond.
Yes.
Yeah. So now if you have taken, they are saying that you dropped the ball, you strike the ball with some energy. We don't know that. But after hitting the ground, that energy is reduced by how much percentage? Everybody? That energy is reduced by how much percentage? 40%. Means remaining, how much energy is remaining? Anybody? How much energy is remaining?
60%.
60% energy is remaining. So what is the height it will be bouncing back, they are asking. So it's very, very simple question basically, but let us see how much it is. Now, if let me consider, is there mentioning anything mass of the ball here? No, they have not mentioned. So let the mass of the ball is M. Everybody do it. Okay. So we will take initial potential energy. It is dropped from the how much height, everybody? How much height?
10
Yes,
meters.
please. 10 meters. So H is equals to 10 meters. And what is the G value, Amma? 10 meter per second square. So what is the initial potential energy? If the ball is dropped from a height of 10 meters, so what is the initial potential energy? For that is what is the total energy, which is equals to what is the formula? Everybody.
MGH.
MGH.
Mass we don't know. Keep it M. G value is 10. H value is 10. So what is the potential energy, everybody? 100 M joules. M means what? Mass only. Keep it here, everybody.
Yes.
Now you see. So what will happen? So the ball is falling with the 10 meter height. So what is the energy, everybody? 100 M joules. Now, when the ball strikes the ground, what is the energy loss, everybody? When the ball strikes the ground, what is the energy loss, everyone? Yes, please. Energy loss is equals to how much percentage, guys?
40%.
40%.
40%.
Means 40 percentage of what? Total energy. Am I right? Understand, everybody? 40 percentage of total energy. So what do you mean by 40? 40 by 100 into 100 M. Here M means what? Not unit. M means what? What is M
Mass.
here? Mass. So 100 into 100 get cancelled. So what is the energy loss? 40 M. So what is the energy left? Anybody can tell? What is the energy
60
left?
M.
Yeah. So energy left is equals to 100 M minus 40 M, which is equals to how much M, Mama? 60 M. So somebody maybe ask me the question, sir, why are you taking the M continuously? We don't know the mass. So what we will do? So we'll just keep it back. Clear, everybody? Understand, all of you? So that is only we are going to do it. So now let us take, once if it is bouncing back, so definitely it won't bouncing back the same height. So that height I am assuming as a H dash. Any problem for anybody? Are you clear, Amma? Understand? Please respond, guys. So it will be bouncing back to what? Bouncing back to some H dash. So we all know G value is 10, M value is remains constant. So the total energy by the time is equals to M into G into H dash. So what is the total energy left here? Energy left. What is the energy left? All of you.
60
What
M.
is the energy left?
60 M.
Is equals to M into G into H dash. So now, here if you notice it, mass and mass get cancelled. G value we all knows that. How much is the G value? G value how much, Ra?
Meter per second square.
10.
10. So H dash is equals to 60 by 10. H is equals to how many meters? How many meters?
6 meter.
6 meters. Understand? So again the ball will bouncing back. How many meters, everybody? 6 meters. Okay. So that is the answer. So once again I'll explain the question. Listen. So the ball is dropped from a height of 10 meters. The ball energy after hitting the ground, the ball energy is reduced to 40%. That means 40% of energy is lost. So remaining energy only there, so that with that energy it will be bouncing back. So what is the energy left actually, everybody? After hitting the ground, what is the energy left? 60 meters. Are you clear, everyone? All of you? So with the, 60 meters, not 60 M. 60 M. So with that energy, it will be bouncing back. bouncing back means in the sense of it is a what energy going above from the ground, means it is potential energy. So 60 m is equals to mg h dash. Bouncing height is h dash. So if you equate it, you will get h is equals to 6 meters. That's all. Clear, everyone? All of you? Yes, Lingesh. Very good. Lingesh answered all that. So any doubt, Mr. Prudvi? Sam, understand, Sam? Very important question it is.
Yes, sir.
Any doubt you can ask me. But this is what is like we can say CBQs. So which will be future even for competitive exams. Questions, imagine the standard will goes more than this. It's not that less than this. More than this will goes always. So just you have to apply the concepts what you learn. That's all. Do it fast, everybody. Anything doubt, anybody can ask. I hope understand, Shivani, clear, Alfin? Understood? Here mass means don't get confused, it's m, mass. It's not a unit. Okay, everyone? Next. Next question. If an electric iron of 1200 watt is used for 30 minutes every day. How many minutes? 30 minutes every day. Find electric energy consumed in the month of April. So April means how many days? April month. Number of days in April. Number of days in April.
30.
30 days. So we have to find for 30 days, each day 1 minute or 30 minutes. So each day 30 minutes means 30 days. How many minutes, guys? Anybody?
900.
900 minutes. 900 minutes means how many hours, Amma? Okay, I'll teach. So first, if an electrical iron energy consumed, I told you many times, if they ask you for energy consumed, definitely you have to find it in commercial unit. What is the commercial unit of energy? Anybody? Commercial unit of energy.
Kilowatt.
The commercial unit of energy is equals to kilowatt hours, which is equals to unit. So now they have given power of that one is equals to 1200 watt, and per 1 day, what is the time per 1 day? 1 day, how much time it is operated? Everybody, 30 minutes. Okay, so we have to convert into kilowatts. 1200 into 1 watt is equals to how many kilowatts, Ra? 1 watt is equals to how many kilowatts? 1 by 1000.
1 by 1000.
Same way, 1 minute is equals to how many hours, Amma? 1 minute is equals to how many hours?
1 by 60.
hours. Okay. So 0000 cancel. So 12 tens are, which is equals to 1.2 kilowatt. Okay. Or else you write 12 by 10. And this one 31s are 32s are, which is equals to 1 by 2 hour. So now energy is equals to power into time. This is for 1 day. 1 day. So power into time. So power is equals to 1.2, or you write 12 by 10 into time is 1 by 2. So kilowatt hours. So 2 ones are 2 6 are. Next 2 5s are 2 3s are. So what is the per 1 day? How much energy, Amma? Per 1 day, how much energy? Per 1 day, it is equals to 3 by 5 kilowatt hours. Then April month, they are saying. April month means how many hours? How many days? How many days for April month? All of you. 30.
30 days.
April, it is 30 days. So 30 days means 1 day. That is what? 30 days is equals to 30 into power consumed for 1 day. So which is equals to 30 into 3 by 5 kilowatt hours. So 5 ones are 5 6 are 6 threes are 18 kilowatt hours. See that nowhere I have been gone with the right side rough work. You have to also avoid that right side rough work. Understand, everyone? So that is the reason I always will say you never go with the right side calculations. You have to solve Okay, without any kind of maximum of the situations, you are not supposed to use it. Okay, guys, everybody.
Yes, sir.
Yeah. Anybody having any doubt, you can ask. Clear, everyone? Do it fast. Understood? All of you? Solve neatly. Just we have to calculate for 1 day and then we have to make it for what? 30 days. That's all. So 1 day, if it is calculating some energy, then 100 days, it will be, sorry, if it is the April month, 30 days. February means whatever it is. So that you have to know it. That's you remember that. Okay. Number of days. Even 10th class, it will come. You keep it in mind. For this only, we are going to calculate energy. For like electric bill. Electric bill, we are going to calculate it. 10th class, again, it will come in electricity chapter. Where everybody? Next, last question we'll solve. So we'll finish it. See that what is the question? A light and a heavy object have the same momentum. So it's very beautiful question. So remember everyone. So definitely it will improve our skill of solving the numerical. A light and a heavy objects have the same momentum. So momentum remains constant. Their mass is not same. And velocities are not same. But what is same, everybody? Momentum is same. Do you understand, everyone? All of you? Yes, please.
Yes, sir.
Yes, sir.
So how it will be happens actually? So we all knows that if momentum is constant means the one and only way is mass is not constant. They are saying light and heavy object means mass is definitely not constant. But momentum is constant means in the sense of what? One object is having different velocity, another object is having different velocity. So that both momentum will be equal. Do you understand, everyone? All of you?
Yes,
So
sir.
they are saying P1 is equals to P2. Momentum is equal. Find out the ratio of their kinetic energies. Which one has a larger kinetic energy? That is they are asking. So very beautiful question. So like these questions will come, you don't need to worry tension. Just you have to calculate normal. So it's very simple. So momentum is equal. So we proceed now, everybody. Momentum is equal means what? No space. Okay, I'll proceed here. So momentum is equal means what? Meeting is going to end, join back, no problem. We'll finish this question and we'll go. Okay, everyone? Yes? Okay, Lingesh, very good. So we all know momentum is equal, they are saying. Momentum is equal means M1 V1 is equals to M2 V2. Any problem? Now from that I will write it. All of you. M1 divided by M2 is equals to V2 divided by V1. Any problem? You can ask. So now let me take kinetic energy of a first body. EK1 is equals to half into M1 V1 square. Kinetic energy of a second body is equals to half into M2 into V2 square. So now I want to find the ratios. So ratios means what? EK1 divided by EK2 is equals to half into M1 V1 square divided by half into M2 V2 square. So I'll get cancelled.